Here we are in the topic of semiconductors. Yes, the last part which we are having is a transistor as an oscillator. In the last video we have seen the transistor as a feedback circuit, and transistor in the previous topics also we seen the transistor as an amplifier, transistor as a switch also, right now. Means if you see in the semiconductors, total divided into diodes, transistors and logic gates here, digital electronics you can say. Here diodes you have seen their applications also, and the transistor how it works, and transistor can be used as a switch, transistor can be used as an amplifier, transistor as a feedback circuit. Feedback circuit also we have seen right now. In a transistor as an amplifier, what we are doing there for the transistor, if you see this, this is the input of this transistor. We have a what is it, a microammeter. From there the diode, PN junction diode is that transistor is connected here, right? And here we are going to take the output. Here we are giving some input signal is given here, means input AC signal is given to this, right? For an amplifier, the input AC signal, what is the use of the amplifier? Input AC signal is given to this, right? When it enters into the amplifier, after coming out from the amplifier, the strength of the signal is going to be increased. The strength of the signal is going to be increased. Strength of that means input AC signal is given in the amplifier. Means an amplifier requires an input AC signals. Whereas in the case of an oscillator, which we are seeing now, transistor as an oscillator, means this transistor as an oscillator doesn't require the input signal. I'll tell you briefly here. This is the amplifier, we can say here, amplifier. Input AC signal is given here. Input AC signal is given. This way comes out with a strengthened signal by giving some DC power supply is given to this. Correct? Understood here? In an amplifier, in a transistor as an amplifier, we are giving some input signal here. Okay, to strengthen its waveform, strengthen its signal, it requires some DC power supply. We are using a DC power supply. That's what roughly we are using it right now. Okay, that finally the output is having the amplified circuit, means strength of the signal is going to be increased. Whereas in oscillator, transistor as an oscillator, what we are taking here is directly we are giving DC power supply itself. No input of AC supply will get the amplified circuit, amplified signal we are going to get it. Got the difference here? In amplifier we are giving some input AC signal, but in the case of oscillator we are not giving oscillator circuit. We are not giving any input AC signal. Understand here? I'll tell you roughly here. In amplifier, input AC signal is required, whereas the oscillator doesn't require AC signal. Then how, sir? That's what we are going to see now. Okay, no? Very good here. Means it's like a sequence here. It's like a sequence. Up to now, what we have seen, that amplifier and feedback circuit, that all we are going to revise. We are going to mix it here. I'll tell you this here carefully. Before knowing this transistors and oscillator, we have to know one more point. That have you remembered LC oscillations here? LC oscillations, I'll tell you here. An inductor and a capacitors are connected here. Okay? LC oscillations means I'll tell you. LC circuit here. Inductor and a capacitor here. LC circuit means, now what we are doing is we are taking a charged capacitor, fully charged capacitor. This charged capacitor, when it is connected to an inductor, okay, this inductor is not having any energy. The capacitor is having a Q square by QC energy, or of CV square, okay, Q square by QC energy it was having. The capacitor is having Q square by QC energy, right? When this capacitor is connected to an inductor, what happens here is the capacitor starts discharging. The capacitor starts discharging here. The capacitor starts discharging. This capacitor gives this energy, its energy to the inductor. Understand here? Its energy to the inductor. Means when the inductor starts storing its energy, and the energy of the capacitor is going to be decreased, and inductor energy will be increased. After some time, The inductor is totally stores the energy. So the energy stored in the inductor is of L square. Understand it? Now the capacity is almost completely discharged. Correct? But the inductor is having the energy. Now what happens here? Inductor starts discharging here. And this inductor energy is given to the capacitor. Now the capacitor starts charging. Now it retains its energy again here. Then the energy of the inductor is 0. Now capacitor starts discharging. Inductor starts charging. Now the inductor is completely charged. Again what happens here? The inductor starts discharging and the capacitor starts charging. Means this total energy is circulated between these two. One is we can take it as electrical energy, one we can take it as electromagnetic energy. What is it? Electromagnetic energy. Okay na? Magnetic field energy, what we say it as, right now. So this is LC oscillations. Means what is basically happening here is the capacitor is fully charged and this capacitor starts discharging and giving the energy to the inductor. Now the inductor starts discharging and gives that energy to the capacitor. Okay now? So this was going to be happening that here. Now what we are going to see here is LC means transistor as an oscillator. Oscillator. Transistor as an oscillator. Basically this transistor as an oscillator will have three circuits here. One is a tank circuit. What is it here? Tank circuit. Tank circuit means this LC circuit over here. This LC circuit is taken as a tank circuit. Okay, na? And second one is the feedback circuit here. What is it? Feedback circuit. What is the feedback circuit? I have remembered here. The output of the transistor amplifier is given to the again as an input to the amplifier. Understand it? And next we will have the amplifying circuit here. What is it? Amplifying circuit. Understood here? What is happening here is the amplifier will get a signal from this tank circuit and the signal will be strengthened. This signal is given through the feedback again to the amplifier circuit. So that's why the signal will get more strengthened. These are the major parts of this transistor as a oscillator. One part is tank circuit. What it contains an inductor and a capacitor. Okay now, and this is feedback circuit. What is the use of feedback circuit here? The output is taken and given again as an input to strengthen the signals. Okay now, amplify, it increases the amplifier circuit. It wants the input. Okay, we'll see here. I'll tell you here. The diagram, the circuit diagram of this oscillator is transistor as an oscillator is like this. This is collector, this is emitter, NPN transistor here. Okay na? Emitter junction is always forward biased. This is P-type semiconductor positive and this is negative. Correct? And now we are having the output here. In the output circuit, what we are doing here is 1 minute. This is input. Okay, input this. Yeah. Now I am having here this is the tank circuit. Understand? Now this is collector. Collector is N-type. Collector junction is reverse biased. N-type is connected, should be connected to the positive terminal of the battery. And here I am having a switch here. Okay, switch. A switch. Through the switch I am connecting. Okay. One more time. Switch. N-type is connected in reverse bias means positive. Like this is very important. This is the tank circuit, capacitor and inductor. This is the tank circuit. Transistor acts as an amplifying circuit, and this one acts as a feedback circuit here. Okay, na? Here I am going to take the output. Output is taken here. Okay. Have you remembered the mutual inductance? Mutual inductance means when there is a change in the flux of a loop, in a loop, there will be a change, there an EMF will be induced in the secondary coil, right? When there is a change in the flux, Faraday's laws, when there is a change in the flux, that flux passes through another coil means then there will be induced EMF is going to be expressed. That's why these two loops are mutually connected on a thin iron rod. Okay, na? That's what, yeah. Okay, na? Fine. These two acts as a mutual inductance. L1, L2, let it be what happened. Name it. This is some L, let it be output. Now, what's happening? Listen here very carefully here. This is a tank circuit here. Okay? In transistor as an amplifier, we are giving the input signal there. AC input signal is giving. But here, no input signal, no AC input signal is given here. No AC input signal is given, but in transistor as an amplifier we are giving an input AC signal, but here there is no input signal, no AC input signal. Okay, na? Now how it is going to work, I'll tell you. Listen here, this is a current. Okay, this current which comes out, and the current from here IC, electric current, this is the base current, IE comes here. Okay, let us see here. Listen here, when the switch is closed, okay, when the switch is closed, what happens here? Current starts moving from here, correct? Means the current reaches the I value, maximum value. How much time it will take here? It will take a fraction of time, fraction of seconds, maybe 1 microsecond, okay? It will take very small time. When the switch is closed, the current starts flowing here. Means current has to increase from 0 to I value, 0 to some value, right? Current is increasing. That current will passes through this here. When this current is passing through this capacitor will get charged. This capacitor will get charged means this plate becomes positive, this plate becomes negative. The capacitor will start charging, and the current here increasing here. Means the current where coil is increasing means EMF will be induced. Flux is changing, correct? Listen carefully. When the switch is closed, what is going to be happen? The capacitor is going to be get charged, understood? And this inductor current is increasing, EMF will be induced there. See, when a current is flowing in a straight conductor, some magnetic field is going to be produced. What's the magnetic field in a solenoid? Mu naught Ni, mu naught Ni, correct? So means magnetic field is produced. That magnetic field produces passes through this coil of area A, which are mutually connected here. These two are mutually connected. Means you can connect here also, no problem there. The flux passing through this will passes through this mutually connected. One more time here. When this switch is closed, the capacitor will get charged and the current passing through the coil will be increasing. Current is increasing means magnetic field is increasing. Magnetic field is increasing means magnetic flux is increasing. Flux is changing. There is a change in the flux. The change in the flux passes through this coil. When there is a change in the flux passes through the coil, according to Faraday's law, there is a change in the EMF. There is an induced EMF. When the flux is passing through this coil changes, the EMF will be induced. That EMF passes as an input for this transistor. We are not giving any external AC current, external input signals. We are not giving any external here. We are not giving these all here. But how this input we are getting? We are getting from here. Understood here? I will tell you one more time. When the switch is closed, the capacitor starts getting charged and the current passing through this coil is increasing. When the current is increasing, field is increasing. When B is increasing, flux is increasing. Means flux, there is a change in the flux. When there is a change in the flux, that flux passes through the coil. When there is a change in the flux, EMF will be induced here. That EMF has taken as an input for the transistor. We are not giving any external AC input. The DC itself as using as a AC, means the DC has been converted into a AC. Previously we have seen one device which is used for converting AC into AC into DC. AC into DC, which converts here. AC into DC is converted as a what is it, rectifier, right now? So here DC has been converted into the AC. This is also called as an inverter. What is it? Inverter. We have in our homes, we are having inverters, right now. The AC which we are getting is getting into the charging battery, right now. That battery again discharges here. There we are going to use the oscillator as a circuit. This is okay, na? Understood here? Okay, na? Listen carefully one more time. Here I am not using any AC induced, only the DC is used. This DC current increases, EMF has been induced, that EMF induced will be given as insular. Means EMF AC has been converted. The DC has been converted into AC, so this oscillator is also called as an inverter. Okay, na? When the current loss in our home, when the current is not there in our home, but our light will get means will glowing here, because there the DC, the battery inverter will have, if you see the inverter machine will be there and the battery is there. The battery stores the energy in the form of DC. The DC has been converted into AC by the inverter. Inverter is nothing but oscillator circuit here. Okay, na? This is the working of this oscillator, transistor as an oscillator. Understand here? Okay, I'll tell you one more time. When the switch is closed, the current increases. The EMF passing through this, the current through this coil is changing, means field is changing, means flux changes. When there is a change in the flux, these two are mutually connected. So mutual inductance is, because of the mutual inductance, what happens here? Because of the mutual inductance, I can simply say that there will be a EMF induced in the input. That EMF passes again, and again it comes out here as the output, correct? And again it goes like this, means the input again feeded to the input which is coming out from the output of the transistor, again feed back to this as a input again. Understand here? I'll tell you one more time. When the switch is closed, EMF induced, it passes here and it comes out like this. When it is coming out, again this is given as mutual inductance. Strength is increasing, means which acts as a feedback circuit. Again the output is given as a input for this. Means this acts as a transistor circuit. This one acts as a feedback circuit which is fed back again, and this is given as an input. So in this way, this is multiple times it is going to be increased amplifier. Okay, now when it is charging, okay, happen here, it reaches the maximum value. What is it? When the switch is closed, initially the current increases and reaches the I value, right? When I increases, what happens? Listen carefully, much important point. Initially switch is closed, current increases, reaches maximum, correct? Correct? Now current becomes constant. Understood? Now current becomes a constant, means there is no change in the field here, flux. When there is no change in the flux, what happens here? No EMF will be induced here. One more time, listen. When the switch is closed, current increases, so there is a change in the EMF will be induced here. There is a change in the field, there is a change in the flux. Now the switch is closed. After closing some time, it becomes, the current in the circuit becomes constant because it's a DC source. Current becomes constant, correct? Now there is a change, there is no change in the current. When there is no change in the current, there is no change in the field. When there is no change in the field, there is no change in the flux. When there is no change in the flux, there is no EMF induced here, correct? Then what happens here is the capacitor starts discharging. Here the energy is not there, it was not having any energy. Then what happens? This capacitor starts discharging. Correct? Now the capacitor starts discharging, again we will get some EMF in this, again we will get the EMF. So the discharging is going to be takes place during the charging and during the discharging. Understood here? In this way, we are going to get the amplifier circuit. Roughly I will explain here. When the switch is closed, current increases and EMF, here the field is changing, flux is changing, EMF will be induced. After some time, the current in the circuit by the switch remains constant. When this current becomes constant, there is no change in the flux. When there is no change in the flux, there is no EMF induced. During that, what happens here? The capacitor will get discharged. Capacitor starts discharging. This current produces an EMF in the loop and that passes as it is. Last time, when the switch is closed, the current starts increasing, field is increasing, flux is, there is a change in the flux. That flux creates some EMF in this primary and that is fed to this input. During the switch close only, the capacitor also gets charged. When the switch, after some time, the current in this circuit becomes constant. During that, the capacitor starts discharging. Again, there is a change in the flux. When there is a change in the flux, this causes. This starts, so this energy will be transferred here. Correct? This capacitor discharges and this coil charges. There will be EMF induced. Again, what happens at this energy? Again fed to the capacitor. Now the capacitor starts charging and this starts discharging as LC oscillations. Now the inductor starts discharging whereas the capacitor starts charging. Charge on the capacitor will be increasing, charging, whereas the current in the inductor is decreasing. It was happening. Again, sometimes what happens is the capacitor starts discharging, the charge on the capacitor decreasing, whereas the current in the inductor is increasing. Again, there is a change in the flux. That flux creates the current in the fed as the input for this circuit. Okay, now understood here clearly? Okay, now so very important thing here. Once roughly I will give here, when the switch is closed, current increases, charge current increases, and the field is going to be changed, EMF will be induced, given to the input. Now when the during the switch closing only, the capacitor also starts charging. Okay, now? And now what happens here is, after some time the current becomes constant because it is a DC source which we are giving. When the current constant, the capacitor starts discharging and that energy will be given to this. So this energy is increasing, means current is increasing. Current is in this is capacitor is discharging, current in this inductor is increasing. So that is again there is a change in the flux, EMF continuously we get an oscillating circuit. Okay, now that's why we call this one as a transistor as an oscillator. Transistor as an oscillator. Here we are having the three circuits. One is tank circuit, amplifying circuit, and feedback circuit. Okay, now that's what. So what is the frequency which we require is totally calculated from here. I remember this in AC circuit we get under 2 pi LC. Depending on L and C values, we get the frequency, how much frequency. We can get the multiple times of the frequency here. Okay, now required depending on the L and C values only we can get this multiple times of the frequency of these oscillations we can get it. Okay, now so here we are not using any input AC signal, but in amplifier we are giving the input AC signal. But here we are not giving any input AC signal. The DC itself has been converted into the AC. The device which converts DC into AC is called as inverter. The device which converts AC into DC is called as rectifier. Okay, na? AC current has been converted to DC by a rectifier, whereas a DC converts, whereas an inverter or an oscillator converts a DC circuit, DC current into the AC current. Okay, na? That's what here. With this we complete the transistors also, complete the problems on the transistors. Okay, do not neglect it. Many of your what I find is they're following their own methods here. Please do not follow like that. Follow our videos 100%. Follow our work. After completion of our work, you go to any other work, no problem. Okay, do not neglect it. Do not. We have the very less time here. I mean, hardly in few days we are going to start. I think so. It will be good for us. Okay, right? Fine. Bye. Thank you.